as it was. And so I did this cap for Ryan Gosling, and I did several of the standard caps for the other actors who played Buzz Aldrin and Mike Collins. But one interesting thing about the Armstrong cap is that the standard Snoopy cap has this sweat pad that you could Velcro in and out.
Yeah.
But Neil Armstrong's cap didn't have that pad.
Neil Armstrong doesn't sweat?
Right. That's my joke, is that he's such a cool-headed guy that he didn't need the sweat pad.
That checks out.
But it doesn't even have the Velcro on it, so he couldn't even put that pad in there if he wanted. But
and I'm feeling this. This is real Teflon-coated fabric. Is this this correct?
Yeah, this is the same fabric that the real ones are made out of. It's a Teflon fabric. The thing is, if you look at these caps that are in museums today, they look a little bit faded than this.
Well, actually, here's the one you made for me.
That's the one I made for you.
Yeah, this is much more what they look like today in a museum.
But this, I found out that this fabric actually fades over time.
Really?
So the way they look in museums don't look like the ones in 1969, because they were much darker.
Well, because most people who, I don't want to say aren't paying attention, but a lot of replicas of Snoopy caps make them black and white.
Yeah.
And now I can see, looking at this in a black and white photograph, you would just assume that it's black fabric.
Yeah, it does photograph very dark. But I went with a modern Teflon fabric that was still dark, as opposed, I do have a small amount of vintage stuff that I use on replicas sometimes that has that cross-hatched pattern on it.
Yeah.
But for the movie, I wanted to make them the way they looked back then, so I went with the darker stuff.
When we watch the movie and we see them in the Snoopy caps, those are yours. Those are these caps.
Yeah. So there was a few. I made a few of them, but these were used. They do have makeup and stuff all on them.
That is awesome. Next up.
I don't actually know if this made it into the movie. I did make this. I got a random request for a lot of little things.
Yeah.
But this is a urine collection device.
A UCD.
Yeah. So I guess in the suiting up scene, they wanted to show every piece of equipment that was put on. So I made an exact replica. So the real thing has like a little nozzle here with something that looks like a condom.
Yeah, no, it's I've worn one. Yeah, it is it's a long shell, and inside the shell is a tapered condom that each user cuts to fit themselves. But so this shell that you're wearing is this large tube sticking out of the front of your pants, and when you come out of the dressing room in this, and you're wearing the white under coveralls and this long tube here, and everyone's making eye contact. Everyone's staring each other in the eye.
I asked them if they wanted me to put that on there.
But they didn't.
No. They said, we can't show that. So they just wanted this outer thing that gets on here. But again, I don't know if it made it into the movie. But I did make those.
That's awesome. And you printed this on here.
Yeah, they were made by Whirlpool, so I put the accurate tag on there.
I love it. The spacesuit's made by Playtex, the urine collection device made by Whirlpool.
Yeah.
Tell me about these boots.
Okay, so I didn't make these boots, but they do go with this
The X-15 suit. Okay.
So yeah,
Shall we move to the X-15 suit?
Yeah, I guess so. We'll explain it together. So this was kind of the big ticket item I made for the movie.
Yeah.
Global made the Apollo and the Gemini suits that were used in the movie, but they didn't make an X-15 suit. And so I worked with Mary to make this suit for Ryan.
And I see that, I'm looking at an outer garment and an undergarment. Did you make the entire undergarment as well?
Yeah, everything in here was was made by me.
Oh my gosh.
The real suit was two parts, so you had to don the suit, the orange suit first, and then the silver part went over it that had this integrated harness. But I put a zipper in the back. There's two zippers, and the harness separates there.
So you can put the whole thing on at once.
Just so it was easy to put on, and Ryan did sign it at the end.
Oh, that's awesome!
that was nice.
Did you get to see Did you get to see this being filmed at all?
Yeah, I probably saw every minute that this suit was filmed with. I wasn't going to be that involved in the movie originally. They just wanted that stuff. But once I made the X-15 suit, I was kind of the only person that knew how to operate it and put it on. So they
Right.
would fly me out to Atlanta just to stick this on Ryan and put all the stuff on and fix it if it broke on set.
Was he nice to work with?
Oh yeah, he was very, very friendly.
That's
and,
awesome.
Actually, the highlight though for me, it was very cool to meet Ryan Gosling, but the highlight was meeting Joe Engel, who was the last living X-15 pilot, and he was also the second space shuttle commander.
Wow.
He was the technical advisor for all the X-15 stuff.
Yeah.
And he just loved this suit. And,
Did he?
And, yeah, he told me he got onto set and he looked at the X-15 mock-ups they had done in the cockpit, and he was very interested, and he kept saying, well, where's the suit, the pressure suit? I think he had a real, I've met a lot of astronauts now, and some of them have a real nostalgic attachment to the suits that they wore.
Yeah.
So he saw this, and he was really, I think he was having kind of a moment. He tried on the gloves, and he said this was definitely the sexiest suit that he ever wore. He wore Apollo suits because he trained for Apollo.
Yeah.
He wore the shuttle suits. He said this was his favorite.
Really?
Yeah. So that was a highlight.
Now it was a really beautiful silver fabric you found for this outer shell.
Yeah, I didn't find it. I was given this fabric by the costume department.
Ah.
So it is like an
So they had done the
aluminized
research they
nylon-
needed to
yeah.
for the right reflectivity and et cetera.
Yeah. This is actually thinner than the real silver fabric on it. They had one made that was more accurate.
Yeah.
It was heavier, but Mary didn't like the texture of it, the way that it looked. I actually
Right.
learned a lot about texture from working with her because there were things that she likes all of these like kind of
The little wrinkles.
the little wrinkles, and she said like when you sew it and there's these little the ripples that develop, she said don't try and fix that. She said leave that all in there. That looks really good on camera. So
that's
when
great.
I make stuff now, I actually try to deliberately make it look a little more textured. But
So you were brought in for your expertise, but the film also gave you some new expertise.
oh yeah, also I learned a lot about weathering,
Yeah.
and mainly that I shouldn't care so much for the weather stuff because it looks much better when you just kind of throw it on there and you're not super meticulous about it.
Right.
So they weathered this suit, and just like sometimes you just see like a brush with a paint that was stuck on there, but yeah, they supplied me with that silver fabric.
And the helmet is a scratch build from you, yes?
Yeah, I scratch built this helmet, and you actually helped with this helmet because you had a Navy Mark IV shell.
Yes.
So this was a very quick job. I think I did this whole suit in about a month and a half, and so I didn't have a chance to mold a real X-15 helmet.
Right.
They're actually very rare. It's much easier to find reference for Apollo stuff than it is for these suits.
Really?
Because all the Apollo suits have been preserved and they're in
Right.
museums
Right.
and photographed, and there's only a couple of these on display anywhere. I have a friend who has one, and he let me examine it a little bit. But this was pretty much just scratch built from pictures.
Wow.
And I used a shell that you provided and then sculpted on all of these additional details. But
I love this this neoprene face gasket. This is a kind of system called an open system in which the oxygen is just pressurized
Right.
around your face. And I wore a system like this when I flew in the U-2 plane, and this looks exactly right. Like even close up to me, having put that system on, it looks like spot on.
Yeah, well, that's kind of an interesting story because I made this mask out of neoprene,
Yeah.
but I didn't have, Ryan Gosling there in my shop while I was making
Yeah.
it, and these things had to fit against the face really well.
Yeah.
And so I was like, well, how can I make a mask that I know when I get on set will fit him
Yeah.
without actually having him to test? And so I embedded armature wire in the neoprene mask so that when we got on set, I could just kind of mold it. And it fit really well.
And that actually makes it more comfortable for him too, because
Yeah,
it's
yeah.
not like pressurized against his face.
Right.
It's just sitting there.
But that worked out well. I'm just lucky. Everything that I made happened to fit him really well.
I really like the gold lines on this visor. Having looked at a lot of pictures of these pieces and stuff, this for some reason makes it feel, this is the veracity that I was like, you know, obsessed about and thinking, oh, that's just exactly what it should look like.
Yeah, that was part of some kind of defrosting system that they had on these masks. This is just like a Mylar graphic tape that I applied. So the real one looks a little bit different, like up close, but from, you know, a couple feet away, it looks pretty much how the real
It looks
helmet
fantastic.
looked.
And now you also did this suit here for the film.
I made a couple of Gemini suits. Well, I just rented them to them that they used for like stand-ins and lighting and that sort of thing. But they did actually use the harnesses I made in the movie.
Oh, okay. And this is like a life vest, right? You pull on this and it inflates.
Yeah. So the harness, these fittings, I think they're Koch fittings.
Koch fitting. Yep.
They plugged into the ejection seat of the Gemini craft, and I actually used real fittings.
They're not hard to find these days.
No, they could be a little bit pricey, but you can still find them. But one of the issues that I warned the production about, and they didn't really listen at first, was that everything it's not like a science fiction movie where you can kind of make up how the suit buckles in. Like there was actual real hardware on the suits that was meant to interface with the spacecraft.
Right.
So I said, you know, whoever's making the spacecraft, which was the art department, needs to put the correct thing in there.
That this fits into,
yeah.
right.
So, I mean, the costume people have millions of things to think about, so I don't think they were paying attention, but sure enough, I think it was like the day before they shot the Gemini stuff, I was going to Atlanta, and they asked me, do you have like the buckles that go in the spacecraft? I said, no, I don't. So it was like a mad dash. I finally found a place, some antique dealer who deals in like aircraft parts that had these pieces, but they actually do work in the Gemini capsule that they created.
I mean, despite small things like that, you know, when they call you originally to participate in this film, and you're thinking, being the obsessive maker I know you to be, we'll see how exacting they are. It must be really refreshing that they were so exacting and that they really appreciated the level of detail you brought to it.
Oh yeah, definitely. They were very thankful and appreciative at the end, because I also did a lot of consulting, just about random little bits.
Little details that you knew from poring over this information.
I mean, it's nice that all of that obsessive research could actually be used for something.
Well, it's not like there's some guy at NASA who's 98 and is still there from the 50s. This institutional knowledge gets lost unless it gets picked up by people like you and me.
Yeah.
Just enjoying the exactitude.
Yeah.
So you have institutional knowledge that was really useful for the film.
Yeah, that's true. There's a lot of details that I found on the suits that I've talked to real engineers at ILC and stuff, and they don't even remember that these were things that were done. Just little details, and so sometimes I think I might be the only one in the world who remembers this, because a lot of those people have either forgotten about it or they've passed away.
Are you writing this stuff down?
I guess I should.
I tend to do this. I like, as I'm gathering information for a project, I tend to keep an open document of my research because, well, I'm older than you are, so things are starting to leave my brain now. So I have to keep a repository of that knowledge. But so you built the Gemini suit, but this Gemini suit wasn't used in the film.
No, this isn't used in the film. I just made this because I always wanted to make a Gemini suit.
Yeah.
And I did end up renting it to them, so they did do some, you know, stand-in kind of stuff with it. But then I put, because you wanted a Gemini suit, I put your name on there.
We made a deal for this suit. Now, you also make gloves. These gloves are, like, they're really gorgeous.
Oh, thank you. Yeah.
I really, like, I actually went and got a mannequin arm with articulating
that's
fingers.
a good idea.
Just to properly show off the gloves on this suit.
Yeah, gloves are tough because it's the pieces are so small that you have to work really carefully. I don't really like making gloves. In fact, when they wanted a Gemini suit just for stand-ins, I'm like, you don't need the gloves, right? And they're like, yeah, we want everything. So I was like, okay. I wanted to make gloves anyway, so it really pushed me to do that work, to put in the effort. And I'm glad I did now, because I have patterns for all of these things.
But I mean, I haven't made gloves, but it strikes me that the order of operations is really important. Like once you've done one seam, you can't do another one, so you have to kind of choose literally which finger part goes in which part first.
Right. I often change little things on the gloves, even if there's a seam that I notice isn't on the real thing, but I know it'll make the construction like 10 times
A little bit easier, yeah.
Then I'll add in a seam there.
Oh, I appreciate that.
Yeah. So like these gussets that go around the fingers, they aren't, this is one continuous piece that goes all around the glove.
Right,
it's just easier to sew it that way.
Right.
The real thing kind of has individual pieces for each thing.
Right.
So yeah, I change stuff like that. I change stuff all the time on the suits I make if I don't think it'll be noticed.
Yeah. So now, do you have any future film projects planned? Has anyone else reached out to you? You know, I'm curious how much of this work you want to do.
Yeah. Well, I wasn't really that interested in doing movie work. I like making stuff for collectors or museums. And a few other productions have contacted me about doing spacesuit stuff, and I've turned them down just because I don't really want to do movie work. But for First Man, I made an exception because I knew that it was going to be about a real thing, about Apollo 11, something that I was very much interested in.
Deeply inculcated with, yeah.
And I know that they, like, so I made my first spacesuit when I was 14 years old, after I saw Apollo 13, because I saw those Apollo suits in the movie, and I was like, I got to have one of those. And so it kind of set me off on this whole life path of making these spacesuit replicas. So when this movie came along about Apollo 11, I knew that like they don't make movies about the Apollo program very often, and that like maybe some of the suit work that I do in this movie will be seen by, you know, some kid, and they'll think, wow, that looks really cool, I want to make one. And so I thought it was kind of a way of like continuing on the tradition a little bit.
And a little bit of having a conversation with 14-year-old Ryan.
Yeah, that's right.
Yeah, like, I mean, it'd be funny if you could go back and tell him how well it turns out.
Yeah.
From humble beginnings to making the suit parts for Ryan Gosling. Ryan, as always, I find your work inspiring and even a little intimidating. Your exactitude is so rewarding to me to like get up and close and see. I really appreciate you bringing this stuff to show us at Tested.
Well, thank you very much, Adam.
Thanks very much, man. And now we're going to geek out off camera and talk about the future spacesuit projects we're working on. Greetings, Earthlings. Well, we visited Ryan Nagata's shop, and I am wearing the beautiful AL7 suit that he made for me. And we'll do a separate video that covers the beautiful features of this suit. But for right now, my one-day build today is I'm going to make some parts for this suit. First and foremost, he's got a wonderful bit of accuracy here, and then in this leg pocket, there is a port right here, and that port houses what's called a dosimeter. It's a radiation dose detector, and it tells you whether the dose of radiation you've gotten is safe or past the norm. So I'm going to make a master pattern of the dosimeter and send it to Ryan for casting and detailing. Secondly, I am going to make some knobs for the RCU. This is the remote control unit that sits in the front when you're doing extravehicular activity. These are some wooden masters that were what he had. I'm going to remake these out of aluminum at a much higher fidelity to the blueprints that we have from NASA, because we have some blueprints from NASA. And that's the one-day build. It's going to build probably 4 separate little parts. It's almost all going to be on my milling machine and my lathe. Let's get started. First up, I got to get out of this suit. All right, the first part I'm going to replicate is this. It's got 8 little details around it and details here for knurling, for turning this knob. This is the most complicated part I'm going to make today, so I'm going to make it first because I like to do the hard stuff up front. I'm going to be using my dividing head on the mill, but first I'm going to turn the material down to the correct diameter. That's this heavy aluminum stock on the lathe. Let's get started. Yeah, okay. 1.9 inches in diameter. So this is going to be 2. So I just want to pull off 100 thou. Just double check my measurement there. There she blows. All right, let's see here. Grab a center drill. Check that. Oh yeah, good, good, good. This operation of using a cutoff tool to separate a big piece of stock from the lathe, one of the scariest operations for me. I just don't like doing it, so I always do it at a very slow speed. It means nothing gets too far out of control. And I use lots of coolant. Keep my blade sharp. There it comes. There we are. Beauty. Okay. Over to the mill. That right there is an indexing head. You're about to see the wonders of this machine. I love it very much. I want to set this 0. Great. Yeah, that should do it. So there's 8 of them. Coming at 1/8 of an inch? A little less, 0.1, 100 thou. Okay. So what I need to do is to make these circular detents times 8 all the way around the perimeter of this stock. The way I'm going to do that is I'm going to plunge this 1/2 inch milling bit 8 times down. Now I'm going to make sure it's in the exact right position by using this index head and turning it. Now I have 8 detents to carve around a 360-degree perimeter, which means I'm going to plunge one every 45 degrees. I'm going to make sure it's exactly 100 thou in. So I'll do this and turn this until it's there. Bring this into. There we go. Okay. Now I'm going to lock my milling table so it can't move. I'm going to set this at 0. And I'm going to lock it as well. It's always good to lock everything down so as little can move as possible. There we go. Here comes the first cut. Beautiful. Set that depth right there, so I can't go lower than that. Excellent. Then it'll all be the same. Unlock, turn 45 degrees. Unlock. 45. There we go. Lock and plunge. Unlock. 45 more degrees, this time to 90. Lock and plunge. Excellent. Now I have to carve these lines in the same piece. And this is actually quite a different operation. This is going to be trickier. I'm going to have to do a little math to start, and then I'm going to have to set this. It's a long story, but basically I'm going to put a right angle horizontal milling attachment onto the spindle of this, lower this, and make this horizontal so I can use a slitting saw. Here we go. Let's see if this... All right, let's give this a shot. It's always good to lock everything down so as little can move as possible. Milling operations are the very definition of measure twice, cut once. And I measured everything and got it all pretty in line to make my first slice. And then I forgot that down. Yeah. So I cut this piece wrong, and now I have to do this again from scratch. What a bonehead. What a frickin' bonehead. Here we go. All right, I'm back to 0. I have made my flute cuts here with a 1/2-inch milling bit, and I'm about to try and cut the lines again. Let's see if I can get it right this time. .36. So that's also 0.36. So 0.18. Let's see. Come in. All right, so I'm getting my positioning close here. Here's the thing. This is a piece of aesthetic hardware, so I don't have to be crazy precise, but visually I need to be pretty darn precise. So I think I'm dialed right in here. The question is, how far? No, how deep do I want to go? And the answer is, I want to go really about 30 thou? Yeah, 30 thou. Okay, so if I dial this in to 0, and I've got that, and I dial this up 20 and 30. So that'll be the cut. Locked, 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 locked. Double check. Locked. Locked. Good. All right. Let's see what we got. Ah! Ha! Ha 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 ha! I hadn't locked that in. Nice. Okay. Okay. Good thing I checked. I want to be right on the center there. Hold on. One last little. So close. Okay, good. Locking that. I'm going to 0 that. That. Put that there. Come back here. Come back up. And lock. And where do we stand here? Okay, here we go. Back to 0. I'm locked there. Up 30 thou. And here we go. That looks darn good. So now 22 and a half minus 6 equals 16.5. 16.5 and 112 is 106.5 and 118.5. $96.5, 331.5, and 343.5. All right, here we go. Let's see here. 16.5. All right, I've messed it up again. Cut to a close-up. Yeah, you can see how it's just totally off kilter. My problem is my registration on what is center and what is not is messing up. So I need to rethink my set of operations here. I know there's some of you actual machinists out there who are like, you idiot, all you need to do is blah, 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 blah. And that's the problem of being a generalist. I didn't think this all the way through. So I'm going to rejigger, and I think I'm going to pull out this right angle arrangement and stop using the slitting saw and start using a nice thin baby milling bit so that all my operations are down and I only ever have to center this thing once, and that's it. That's the trick. It's the switching operations that's messing me up. So, once more into the breach, dear friends. Okay. All right, now to cut the circular flutes. So I changed my order of operations. In the beginning, I cut the semicircular flutes out of the side first, and then I was cutting little knurling slots, and I was having trouble aligning. So this time I cut the knurling slots first, and now I'm cutting the semicircular flutes. Hopefully that'll give me a little better control, and I'll be able to see that I'm screwing up before it's past the point of no return. 2 bad attempts so far. I don't want a third. Tool of choice now is a ball end mill. And I haven't moved any of my arrangements. I haven't had to reset my XY table here. And that's pretty important. That is pretty darn important. That's the next one. Next one is 90. Next one is 315. And that's the last one. That might be it. I might have gotten all the cuts. Let's double check. That looks pretty darn good. All right. Awesome. Whew. That was a much tougher job than I thought it would be. Good, good, good. .43 inches thick. That's where I'm at. We make this final cut. This part is done. I don't mind telling you, I'm happy to see it go. Awesome. A little bit of finishing. Looking good. Next part. Now I'm making this part, the little dial knob that goes on top of this. I want to make this one out of Delrin instead of aluminum because I want my life to be a little easier. That's the one. Let's see what I can do here. there is the knob, and I'm very happy with that and how that looks. It's a nice little part. They fit together well. Now I've got to do a little bit of detailing. I've got to drill a couple holes and then we're done. I'm going to drill one hole right there. Is that 40? 40? 40? 40. Okay. I have carefully made this dial in Delrin, and I've accidentally combined features of both the dial at the top of the remote control unit and the bottom. I've made an amalgam of both of those dials, and this doesn't work for either one. I'm out of sorts today. This is just one of those days when nothing's quite going right. I'm pretty frustrated. I'm just going to get back to it. Oh! Just a little relaxing millipede before I get back into it. It's like that bit in The Office when she's like, my plan for this race is to run really fast at the beginning and then run really fast in the middle and then run fast at the end. The last cut. was it. Let's see if I can open this up. You are pretty darn good. My dials. They're mostly done. Got just a little bit of a ding in there. I'm going to fill it with the acrylic from the cyanoacrylate glue, or crazy glue, and then I'm going to sand it down. For those of you who are wondering if my frustration was real, it was. But, you know, there is something that you learn when you do this stuff poorly, which is the order of operations. I was making all my cuts kind of bass-ackwards. So now I have a better understanding of how to kind of think through a shape like this when you're making it, and consequently, I'm a little better for it. Yeah. Nice. Awesome. All right, the last bit of Apollo hardware for this one-day build is the dosimeter, actually the dosimeter pattern master. Now, the dosimeter went in this right-hand leg pocket of the astronauts, and it told them how much radiation they were getting. There's no protection from solar radiation and cosmic rays on the moon. Astronauts need to know how much they're getting, and the dosimeter told them. It's a little device. Now, I've had some trouble figuring out the exact dimensions of a dosimeter, but luckily one just came up for auction, and they listed its dimensions. So I'm going to pull it up on my computer, make some notes, and we're going to make it out of one of my favorite materials I have not yet used untested. All right. So what is up for auction is Deke Slayton's personal radiation dosimeter. It is a fairly simple soap bar shaped object, and the auction listing says it is 2 1/4 inches by 3 inches by 3/4 of an inch. That is everything I need to replicate this. Now, it also has a little display of numbers, but I think we're going to cheat that. Again, I'm making a pattern master to send to Ryan Nagata, who will make, mold, and cast these, and also do the what do you call them? The foil stickers for them. So let's get started. I know that as somebody who started out working shop with very little budget, I love the cheap and easy materials. This is not one of the cheap materials, although it is one of the easiest. This is a product called RenShape, and it's expensive and amazing. RenShape is effectively a prototyping urethane plastic. It has a difference over any kind of wood in that it has no grain, and wherever you finish it, it finishes uniformly, so you can make smooth shapes out of this stuff all day long. This is one of the cornerstones of high-end special effects model making, because you don't need to do a lot of finishing work once you've carved your basic shape, and that's worth its weight in gold in terms of time. The expense comes in the material itself. This sheet right here, which was originally about this big, it's like $300. It's a lot of dough. But I probably won't work through this sheet in my lifetime for the kind of model making I do. Right now for the dosimeter, I'm going to use a little tiny piece about this big. I'm going to saw it off using a Japanese handsaw. So RenShape is very specifically made as an engineering and prototyping material. It's specifically formulated so that it doesn't dull your milling bits, that you can saw it, sand it, carve it. I mean, it's really, really amazing stuff. I haven't used it a bunch on the tested because, well, it is one of the sort of more materials of the deeper pocketed shops. But boy, I love this stuff. In fact, at a place like Industrial Light and Magic, kind of moving so fast, I'm a little impatient. At a place like Industrial Light and Magic, large chunks of this and not consider the smaller chunks worth saving. And so, like my friend Fawn Davis and I used to go through the dumpster and collect little chunks for our model making shops. There we go. That's my chunk. I'm going to put the bigger piece away now. Now, I'm not just making a single blank for this master. I'm going to start by making 3 of them. I know from hard-won experience that I'm likely to screw this up, so I'm going to take it carefully. All right, I want 2 1/4 by 3 by 3/4 of an inch. Again, I save every chunk of wren shape. It's precious, precious gold. Here's my thing. I could make more of these cuts on the table saw, but I hate working with the table saw with the blade this high. It sort of freaks me out. So I'm going to pause on this, and I'm going to move over to the bandsaw. Just feel a lot better that way. Be able to get 4 prototypes out of this. Always better to have too many to start with than too few. All right. To the bandsaw, boy wonder. Now I'm off to the disc sander to make all my edges perfectly square. Nice. You see how easily the wren shape actually sands. This is both its awesomeness and the thing that's most dangerous about it is that it sands so quickly you can actually take off more material than you want. Oh, nice. Awesome. Good. Uh-huh. Wait a second. Better. That's a B grade piece. There she blows. All right. So here's the reason I went for 4, because out of the 4 pieces I cut, 3 are really tight and great. 1 is just okay. So I'm going to toss this one out, put it in the wren-shaped scrap pile. My disc sander is about 120 grit. I want these to be smoother, so I'm going to take them further down on a 180 grit piece of sandpaper, make them really nice. This is going to be a casting master, and even though Ryan's probably going to coat it with primer, I want it to be really nice. I agree with you. That does sound like farting. Let's see where we're at. Great. Great. Awesome. Awesome. In every case, I'm within 10th thou, which for a model like this is just great. Let me clean up and take a shower. So I see a few details here that are worth noting. I see some circles on the top. I see a place where the numbers go. So let us, yeah, I think that we can stick a little piece of acrylic in there with a sticker behind it and we should be good. Now, the way I'm going to figure out the size of this is actually, I am going to just get it to be the correct size on my computer screen and measure it off of that. It's, you know, if I had a lot of time, I would go towards, there we go. If I had a lot of time, I would go towards printing this out, but this should be just fine. So, my number screen is centered. We're good. Okay, cool. So, my number screen is ½ an inch wide. How tall is it? .2, and it is how far from the top? All right, that is a much smaller little number counter than I thought it would be, but apparently that's the size it is. Let me just double check this with some of my other reference material. Yeah, you're pretty close. ½ an inch wide. Yep. Okay. This is a piece of reference I gathered a few months ago. It's not quite as straight on a shot as the one I just got from the auction, but it confirms my measurements for this. So this right here is the window that I'm going to cut out. But just for double, triple, quadruple checking, I'm going to put it in the pocket where the dosimeter actually goes and see if it fits Ryan's sewing pattern. Let's see here. Oh, right, I've got to soften the end. That's for sure. But if I do, yeah, if I soften the end, the display shows up right in there. That's just where I want it. So we should be good. Excellent. I think it's time to start machining. All right. This is a very tiny machining operation, so I'm going to use a tiny milling bit. That is a tiny milling bit. It's 1/16. I'm only going to go in about 1/8 of an inch. Yeah, about 1/8 of an inch and carve out this little hole. If I was doing a actual bit of mechanical machining, like a machine that had to work together, I would do a couple things. One, I would tram in my vise so it was accurate to less than 1,000th X, Y, and Z. This is just a prop. I don't need to spend the extra half hour doing that right now. Second, I would probably take some critical measurements and use my DRO to make sure the box I'm making is exactly the right size. But for this one, I'm just going to use my eye because that's going to be plenty good enough given my pencil lines. Okay. It's 100 thou, 120, and 5. There we go. That's a full 1/8 of an inch. All right, there's a corner. I'm going to set it at 0. I've got to proceed slowly. I don't want to break this bit. That is great. That is a lovely 1/8 inch deep hole. I don't even see that I need to square off the edges. That's a nice little bit of detail. All right, now for the circles. All right, now this is, there we go. Excellent. Okay, cool. So now, how wide are these screw heads? bingo. It's 256. Wow. That is 0.6. 0.6. Good. I like that. All right, so that's going to be my 0 point. These are just going to be plunge cuts like this. Then I'm going to move up 0.6. All right. Yes.
Often while working in ZBrush, you're going to want to hide and show specific areas of your model. To do this, all you need to do is hold down the Control and Shift key. We'll then click and drag to make a selection. Anything inside this selection will remain in view. If you want to invert this selection, hold down Control and Shift, and then click and drag in an empty area. To bring the rest of your model back while holding Control and Shift, just
Those should be my 4 countersunk holes. Those look beautiful. Just take a moment to take a look at these really nice and close up. They're really pretty. I'm kind of proud of them. They don't need to be these. They could be the shorter ones. That's no good. No shite. Ah, bellissimo. If I was doing mechanical stuff, I'd be threading these and being a little more careful, but because this is just a visual piece, it's just aesthetic, I'm being a little looser with some of my tolerances. But again, this is looking darned good. We're going to do a test cut on this before I cut this, because I've already put so much time in it, I don't want to screw it up. I'm going to do a test cut on my secondary piece. Well, that seems to make a very nice, gentle cut, and it's damn close to the edges, so I think we're pretty good. I think I can actually... How am I going to make a wren-shaped plug that fits that exactly and looks just like the battery holder? I'm going to do it by using a circle template and some wren shapes. So check this out. Here we go. I'm going to draw that, and I'll draw a second one just for good measure. To the bandsaw. To the belt sander. Did I say belt sander? I meant disc sander. Now I didn't need the tube that I was cutting, the rod of wren shape, to be absolutely perfect. I just needed it to be close enough so I could stably grab it with the 3 jaws of the chuck of my lathe. Now I'm going to machine it down to exactly 3/4 of an inch so that it fits the hole exactly. Now, before I cut this down to size, I need to cut a slot in its end, specifically a coin slot, so that you could use a quarter to open it, as it seems you can on the dosimeter. There it is. That's what I wanted. Is that what I wanted? That's it. There she blows. Good. There we go. Excellent. I'm going to lock that, turn that. Now, I cut this off and put it in my lathe and slice the piece. Ah, look at that. It's beautiful. All right. Sand this whole thing down. Now to sand down the bottom of my dosimeter. All right, now I want to crazy glue in the battery holder. One drop ought to do it. Do it on a nice angle there. And there it is. That's the last of the Apollo objects for today's one-day build. Now I want to add a little coda on this. We actually shot this over 2 days. I know we called it a one-day build. In the end, it was about 8 or 9 hours worth of work, Joey? Yeah, 8 or 9 hours. When I finished screwing up those dials, like I built each one 3 times and kept on munging them, it was actually one of those dark days of like, this has been my living, and yet I was brought so low by screwing those things up so many times.
Hey Adam, we're in your cave for today it's about a time for a one-day build.
It is. It's been too long. I've been gone for a while. I'm back. So yeah, I wanted to build something. In fact, I wanted to build 2 of something today.
All right, what are you gonna build today?
We are going to attack Barbarella's rifle. This is an iconic piece of sort of Frazetta science fiction weirdness, this beautiful, ornate, amorphous rifle.
And this photo, I mean, this promo photo,
iconic.
it's super iconic.
Of beautiful, beautiful Jane Fonda. I mean, she's incredibly sexy. And this rifle is just a far out piece of, like, right from the cover of a science fiction novel.
Now, I must confess, I've never seen this movie. How much reference material is there for this specific rifle?
This is what I got.
Okay, that's it. Well, it's a very distinct silhouette.
It is a very distinct silhouette, and I'm going to make some assumptions about its width and thickness based on some of the things that I can see here, and I'm just going to knock a couple out. I'm knocking 2 out. I want one for my shop, but I've got a friend who also wants one, so I'm going to make them for them as well.
All right, looking at this picture, and I'm sure you've studied this picture for a while.
Yeah.
You know there are different materials. There's metal, there's wood here. What processes are you going through your mind?
One is metal turning for the front here, some finishes. Specifically, I don't think I'm going to use a hardwood for this. I'm going to use a softwood. I'm going to make it look like it's a hardwood and then try and get a nice gloss coat on it. It's designed to look sort of like a piece of furniture, like a real high gloss finish. So that's going to be tricky to get because that can take time, and I don't want to take a lot of time. I want to get this knocked out. So I'm going to dredge up some of my old model making tricks to kind of make this look right.
All right, what's step 1?
Figure out how big it is.
Okay.
And I'm going to guess that Jane Fonda's probably about 5'7", which would place this thing probably 3 or 4 inches shorter than her. So I'm going to say the overall length is probably 62 inches. What do you think?
Yeah. We can confirm. I'll find out.
Actually, hold on a second. How tall is Jane Fonda?
Looking.
Oh, technology.
This on the web for how tall is Jane Fonda?
5 feet 6.5 inches.
Wow,
I
pretty
was
good
damn
guess.
Close.
Also, the internet is creepy.
Yes, the internet is totally creepy. I don't want to say, hey, what's Jane Fonda doing right now? So if that's half of her head would be, yeah, about 8 inches. So 4 inches, yes. So 5 foot 6.5. There's 5 foot 6.5, and we take 4 inches off of that, 5 foot 2.5, 62.5 inches. Okay, so if this is 62.5, 62.5, and now currently 9 inches. 9. What is that factor? So 6.9, so 7. This is a 1 to 7. So every measurement here gets increased by 7. Let's see. Actually, I probably want to grid on top of this. So if I take a do this. Every 6 inches. So 9 divided by 7 equals 1.28. So 1.28 inches is 6 inches. This will be rough, but it'll be close enough.
So on your calipers, you've marked off 1.28 inches, and every 1.28 inches that you've marked off here is multiplied by a factor of 7.
Yeah. I'll double check this.
Yeah, I'm going to calculator also. You want half-foot increments?
What's that?
You want half-foot every one of these should be
Yeah,
half a
about
foot?
every 6 inches will be reasonable for me to grid this onto a piece of wood and cut it out.
I don't think it's 1.2. 6 divided by 7.
Oh,
It's every 0.85 inches.
Oh, I was doing, right. 9, I was doing 9 divided, right, that's silly. What is that?
0.857
Thank
inches.
you. 857, okay. This is why you check and double check. Let us do this. Mount this, tape this down to so 0.85 inches.
So Adam, you're you're making a grid here on the
Yes.
printout, and you've measured it so that 0.856 inches on your paper.
Yeah.
Every 0.856 inches is going to equal to 6 inches, half a foot.
Right.
So when you mark that on your wood, you know how that's going to scale.
Exactly, and this will allow me to transfer the design of this right onto a big piece of wood, so I can just start cutting it out and shaping it. Okay, that checks out, just over 5 feet. Let's break out the wood I'm going to do this on.
All right, Adam, looks like you're using MDF here.
This is actually, LDF. Light density fiberboard.
Even lighter.
Yeah, this is Trupan. This is, if you lift it, you'll see it's really lightweight. It's actually made from sustainable pine forest. It does not have a formaldehyde binder like normal MDF does, which means it's much less toxic. And it's a really kind of one of the most important modeling materials. And you'll see what I can get done with it. 6, 12, 18, 24, 30, 36. That's awesome. Okay. So now I transfer.
Drawing.
Yes. So try and make reference marks to.
Where the edges intersect your grid lines. That's easy to approximate. And then you draw your curves based on that.
Yeah. Yes. That's feeling pretty good. That looks like, this is a single piece with this sticking out of the top. So I think that'll be a separate piece.
Now you're doing this by freehand. Some people, I imagine, could also just print out a large
Absolutely.
scale and then cut out pieces and trace
Yeah, and when I worked at ILM, we did it in every different way. Sometimes we would put these on slides and project them. Sometimes we put them in an opaque projector and project them. Sometimes we put them on a computer on a digital projector and trace them. Other times, full printouts. Transferring things from small to large is a multitude of ways. This is sort of the lowest tech, but actually, and I'm doing 6-inch grids because I feel pretty comfortable with how amorphous this shape is. If I wanted total accuracy, I'd probably go to a 2-inch grid, something even finer. Yeah.
What are the things you're looking for?
So it's like, it's looking at it both from a micro scale and a macro scale. So I look at it like a close up and okay, that's about this far, that much percentage of a grid square, etc. And then I step back and I think, okay, am I hitting my general marks? Is the fluidity right, actually, you know? Because there's a gesture to the prop too. And if it's a choice between what looks like an absolutely correct measurement or something that feels more like the original, I'll go for the thing that feels more like the original.
Like looking here, you can tell this part's really wide, and then you want to make sure that is represented.
Exactly. And this is going to get rounded and messed with.
What about the bottom? I think that there's more, goes down lower.
You think this horn is a little
This
wider?
horn is a little wider.
Maybe more like this?
Yep. And I think that the thickness here should be a little wider as well.
Oh,
or down here.
all right.
I don't know if you agree there.
Let's see. Yeah, I see what you mean. So now the question is, how thick is it? I've got this, and I'm going to cut it out.
And this is just 3/4 inch.
Yeah, so this is 1.5 inches, and I think that that's actually not as thick as it should be. I think it should be a little bit thicker. So I think I'm going to bring in a 3rd sheet, screw them together, cut them in half, and cut out all at once.
Okay.
Okay. That ought to do.
So you have enough here, Adam, for 2 guns, right?
I do.
It's gonna, and you're cutting up to 2 1/4.
I'm going to try.
You're gonna try. Are you gonna do all 6 at once to the bandsaw?
I'm going to give it a shot.
Ooh.
Am I doing that? Let me try it. I'll do 2. I'll do 1 at a time. All right. Let's see here. I'm going to go for the jigsaw.
Adam, you gave it a try with the bandsaw, but now you're going handheld.
Yeah, I don't have the fine control with the bandsaw that I want to get these curves right. So I'm going to go with a jigsaw blade. Sometimes I like to imagine while I'm making these cuts, I'm thinking about the craftspeople who made these same cuts like 50 years ago, right? They only made one.
All right, Adam, you've cut out 3 pieces of MDF. Now
Yeah.
you screwed them together when you did your cutting, and
Yeah.
at some point that gets away from you, right?
Yeah, it does. And I'm being quite loose with this because there's going to be so much shaping involved. Sometimes I would glue the wood together beforehand, but that can be kind of its own pain in the butt. If I had overnight, I would have put down wood glue, clamped all 3, let them sit overnight, then I'd have one big chunk.
Right.
As it is, I've got these 3 pieces. The jigsaw blade wandered a little bit, so not all my cuts are perfectly square.
This is Joseph Drust, and welcome back to another episode of Ask ZBrush. So we had a question sent in asking, how can I display the polyframes across all subtools? So to start off, I just have ZBrush loaded up, and I have the earthquake model here loaded in. And the question is asking about the polyframe functionality inside of ZBrush. So if I have earthquake's body here selected, and then I come over to the side, and I just toggle on this draw polyframe button here, you're going to see that the subtool I have selected is going to now display earthquake with its polyframes. So I'm getting the wireframe of the model, and I'm also getting the color of any polygroups that are associated on that mesh. So the question is asking how I can go by seeing all the polyframes across all the subtools, and not just the only one I have selected. So in order to display all the polyframes across all the subtools in your tool, you just need to do a render while this polyframe button is turned on. So to do this, just make sure you have the polyframe button toggled on, and then just simply come up and do a BPR render. Now, if this polyframe option is active when you do this render, it's now going to go through and render each of the subtools with polyframes. So now you can see I get a result of earthquake here with all his subtools showing polyframe. So you just need to toggle this on and then click render, and then that will render all the subtools in that polyframe mode. Now there also are some different options you can use with the polyframes, and those are correlating to these little buttons on the top of the polyframe button here that's labeled line and fill. Now if I turn off the line button by just simply clicking on the text, and I'll turn that off, you're going to see that the polyframe option is only going to display the polygroups. So I'm just getting the color information and the polygroup breakup on that subtool, and I'm not getting the wireframe. So if you just want to see what the polygrouping on your model looks like, you can just come over here and disable this line function. And then if you want to see that across all your subtools, you can just do another BPR render here. And now you're going to see Earthquake with his model rendered with just the polygroup breakup. Now, in addition to this line function, there's also a fill button too. And this fill button, if we turn this off, is going to disable that polygroup and the polygroup breakup, and you're just going to get the line option if you just have line turned on. So now I'm just getting this wireframe look for the model. And if I want to again display that across all my subtools, I just need to do a render. And now I have Earthquake here being displayed in a wireframe type format. So the options here of line and fill can be toggled on and off to display how those polyframes will be viewed on the mesh. And then once again, just to get the polyframes to display across everything, just simply do a render while you have the polyframe button active. If you have any other questions related to ZBrush pipelines or processes, please use the hashtag AskZ.
Hey guys, Henning and Morten from Flip Normals here. In this tutorial we're going to cover the basics of poly painting in ZBrush and some color theory and general tech painting theory here. We're going to be using this guy here as our little target, and let's just get started with this. First, we're just going to cover briefly some color theory here on how the face works. You can find more information here if you go to James Gurney's blog. Just
whether it's you have visible veins or if it's a lot of fat in that area.
a lot of bone in the area as
Yeah.
well. Like you can see here, like on the brow here, there's not really a whole lot of stuff going on in terms of muscle. And it's pretty much all straight bone. So you get different colors based on the depth here. So again, this is not a hard rule. This is just a tool we use just to get some variation into it. Like really just observe some real skin tones and just see how incredibly rich it is in various hues and general colors. So with all this said here, we're just going to keep this up here, but let's just get started in ZBrush here with poly painting. So when it comes to poly painting, I'm usually just working with a standard brush. Very rarely do I actually change anything at all. And you can see here by default, if you just change the color, you can see that we now get the color on the model. And this changes for the entire model, like for all the tools here. So what we're going to do now is just select a basic color here, something which resembles skin for a Caucasian guy. And we're just going to go crazy and paint over this afterwards. Then we have to go over to color and just set fill object. Here, be aware that the RGB intensity here is the intensity of which will be applied to. If you set this to 10%, it's going to fill it with 10%.
And we're using pure ref to just
Yes.
have our references on top of the window here.
Purif is fantastic.
Yeah.
We keep using this in all our videos, and there's always somebody who's like, "What tool is that?" It's Purif. So now we have a base color here, and now we can essentially start painting. We have to disable Z-add and Z-sub and just enable RGB here.
Otherwise, you'll be sculpting at the same time as you're painting. That can be useful sometimes as well. Maybe you want to add like little, dots to him while you're painting at the same time.
You want little things here.
Exactly.
So that can definitely be useful. Be aware that you can paint at the same time. For this though, the model here is pretty much done. So we're just going to enable RGB, and then we can just start painting here. Before we do this though, let's just enable